So this one is January 2018, Unit 6. We did the first two questions. We'll solve one question from this. Question 3. An experiment is carried out to investigate the kinetics of reaction between iodine and propanol in the presence of hydrogen iodide. You can see the equation is given, and the rate equation is given. Rate is K times the concentration of hydrogen, the propanol, times A, hydrogen ion times B, and iodine times C. A, B, C are representing the order with respect to propanol, hydrogen ion, and iodine. So the order with respect to propanol is 1. This value of A is equals to 1. So if you double the concentration, rate will be double. If you triple the concentration, rate will be 3 times. Propanol, water, and dilute hydrochloric acid are placed in a conical flask. Once the temperature of a mixture has equilibrated, a solution of iodine in potassium iodide is added and a clock is started. At suitable time interval, a known volume of a reaction mixture was transferred in a series of flasks, numbered from 1 to 6, and each flask contained an excess of sodium hydrogen carbonate. The purpose of a sodium hydrogen carbonate is like to quench, so that the reaction will stop or it slow down. Because we can do quenching by either adding any reagent, or we can also do the changing the condition. So flask number 1 to 6 are shown. Then we have to plot a graph for volume of thiosulfate and on y-axis and level x. So because usually with respect to iodine, it is zero order with respect to iodine. So when we plot a graph between the concentration of or a volume of sodium thiosulfate, because the amount of sodium thiosulfate reacting depends on the amount of iodine present. So if we sketch a graph for the volume of the thiosulfate, Na2H2O3, and the time, so the likely result, it will be a straight line with a constant negative gradient, shows it is a zero order with respect to, because thiosulfate is reacting with iodine, so it is zero order with respect to iodine. The next one, the order of with respect to iodine can be determined from a graph. Explain why the actual concentration of iodine does not need to be calculated in this experiment. Like why we don't have to calculate the actual concentration of iodine. So the main reason is that because the concentration of iodine, it depends on the concentration of like amount of iodine or concentration of iodine totally depends on how much thiosulfate is used. So we don't have to actually calculate, like we know the ratio between the iodine and thiosulfate. So if we have more iodine, it means greater amount of thiosulfate is needed. That's why uh, we don't have to directly know the concentration of iodine to work out the rate of reaction. So the simple answer here that iodine concentration is proportional to the volume of thiosulfate. Like higher iodine concentration, greater volume of thiosulfate is needed. In this experiment, the concentration of both propanol and hydrochloric acid are chosen so that it to be a large in excess. Explain why it is necessary to determine C, the order with respect to iodine. So whenever we are carrying out the experiment, like one of the reagents should, or like one should be small quantity and other should be, so that the concentration of a propanol or concentration of a hydrogen ion does not affect the rate of a reaction, or it will, like if it's too large or very high concentration is there, very small change does not affect the rate. So iodine concentration is the only variable we want. So why we use in large excess? So the concentration of propanol and the hydrochloric acid does not change, and it does not affect the rate. Then give the value for a C, the order with respect to iodine. So it is zero order with respect to iodine. How it is zero order? Because it's a constant volume time graph or concentration time graph. The slope represents the rate. So rate is constant. It means it should be a zero order. So value of the C should be zero. And because it's a constant gradient, so rate is constant or rate does not change with volume or concentration. State the indicator used in iodine. Usually iodine thiosulfate titration, what we use starch is used as an indicator. And what is the starch solution or starch? And it is changing from blue black to colorless. So starch is used as an indicator, and original color in the presence of iodine and blue black. And then when iodide ion is produced, then it will turn into colorless. The indicator named in B1 should not be added to the start of a titration. State when the indicator is added to a mixture in a conical flask. Explain why it should not be added at the start. So usually what happens, because it will form a complex, otherwise we need a greater quantity of the solution, because it might form a complex. So when a solution in the reaction mixture, usually when it is light yellow or pale yellow, that time we add iodine. And the main reason is to prevent formation of insoluble complex or insoluble compound, insoluble starch iodine complex. So what time we add indicator? When the solution color changes to light or pale. And the reason is that because iodine and starch can form complex. So as a result of that complex, we need a greater or a larger quantity of thiosulfate for actually how much it goes. The titer obtained from a sample at 18 minutes has a greatest uncertainty. Explain why this is so. So why the titer is having the greatest uncertainty? If you see the table, so we are using, like we record the smallest value. What is a percentage uncertainty? Percentage uncertainty is uncertainty divided by value recorded into 100. So if we record a smaller value, then we'll have a higher percentage uncertainty. So because it's a smallest iter, so it will have the highest percentage answer. Then in a similar experiment, the concentration of a hydrochloric acid was double while keeping the other same. The gradient of a graph uh, data was double for the graph plotted in A1. So if we double the concentration, gradient or rate is double. So what we can deduce about B, we can say it is first order value of a B is first order with the, and how we can say it is first order, because you can see the concentration or the amount, like if we double the concentration, the rate is also doubled. So doubling the concentration, double the rate, or for first order reaction, rate is directly proportional to concentration. So if we double the concentration, we observe the slope or a gradient is double. It means it is first order with respect to hydrogen ion. Then suggest an alternative practical technique which can be used to monitor. Here we can use calorimeter. Suggest an alternative practical technique which can be used to monitor the progress of this reaction and justify your choice. So what we can use, because the iodine molecule is turning into iodide ion. So if an iodine molecule is turning into iodide ion, what we can say about it? That we can use a calorimeter as the color intensity will change. As the iodine molecule changes to iodide ion, so the intensity of a color change or intensity of a light which is passing through it change. Using that, we can also work out the rate or the speed of this chemical reaction. Then the compound 2-ethonyl aminobenzoic acid is there, which is extremely reactive and it's only prepared under strict control condition. Steps of the procedure to prepare these compounds and determine its melting point are there. First, transfer about 3.7 grams of 2-aminobenzoic acid to a dry 50 cm³ pear-shaped flask with a reflux condenser. Then add 7 cm³ of ethynyl chloride in excess and pour it carefully down into a reflux condenser. Then heat the content for a 15 minutes and allow the mixture to cool. Then add 5 cm³ of water. Then heat the solution slowly to boil in few minutes and allow the solution to cool to a room temperature and collect the crystals by using filtration under reduced pressure, then recrystallize and then determine the melting point of the crystals. Explain in terms of changes of state how the process of heating under reflux work and give 2 reasons why it is often necessary to heat chemical under reflux in step 3. So how the heat under reflux works, and then heat the content of pear-shaped flask slowly to a boiling tube and heat under reflux for a 15 minutes. So usually, what is the main purpose of heating a content in a reflux condenser? Because what happens as a liquid boils or vaporize and it cool down by a condenser, so it will return back to the same flask again. So we can heat for a longer period of a time. So and it will also prevent the reactant from escaping and enable the flammable or a harmful liquid to be heated safely. So usually heating under reflux, it's a safe technique to heat a flammable liquid. How it is safe technique to heat a flammable liquid? Like example, this is a condenser. And we have, it is connected to a pear-shaped flask. So when we are supplying heat energy, the content which are there in the flask will turn into vapor and they rise, and the condenser will remove the energy and then it will turn back to liquid state again. And we can heat it for a longer period of a time by using the reflux condenser. So the points, as they ask, explain in terms of changes of state, how the process of heating reflux work. First, what will happen? Heat absorbed by the content in the flask is to turn into vapor, and then the vapors are condenses or vapor condenses by the condenser, turned back to liquid state. And two reasons why often necessary to heat chemical under reflux in step 3. So usually whenever we want to heat a flammable liquids, this is a safe way or safe technique to heat the flammable liquids, enable us to heat a flammable liquid safely. And the second thing, also prevent escaping of the reactant or the product as well, or even the volatile or a flammable liquids. So first, a liquid turn to gas, and then the gas condense to form liquid. And what is the reason why we can heat flammable liquids, or we can also heat volatile liquid with low boiling point. We can heat in the reflux condenser, and it will prevent vapors to escape. And the top part is usually open. Why the top part is usually open? So otherwise, the pressure buildup might cause an explosion. That's why it's not all, this reflux condenser is never sealed. Even a simple distillation or a fractionating column, fractionating column is sealed, but on the side, the part which is attached with the distillate is always open. Give the reason why a water is added in step 4. So what is the purpose of allow a mixture to cool and then add water? So what we are doing, the compound 2-ethonyl aminobenzoic acid is there, which is, and it is prepared under strict control conditions are there. So the main purpose whenever we are adding a water, because the water will have a tendency to, this ethonyl chloride is there as we are preparing this compound from ethonyl chloride. So water will dissolve or mix with this ethonyl chloride, or it will cause a breakdown of ethonyl chloride, or it will react with ethonyl chloride and remove the excess, the unreacted ethonyl chloride. Like here, 7 cm cube of ethanol chloride was there in excess. So how we remove? We add water, because ethanol chloride can react with water and will form an alcohol, and misty fumes of HCl will be there. So as a result, the unreacted ethanol chloride will be removed. So main purpose of step 4 is to remove unreacted ethanol chloride. That is why the reaction mixture was cooled before the water was added in step 4. Usually, when the reactions are highly exothermic, we tend to cool down the mixture. So why the reaction why the reaction was cooled down before the water was added? Because the reason is that the reaction is very exothermic. So when the reaction is very exothermic, we always cool down the mixture. And suggest 2 advantages of using a suction filtration in step 7 compared to normal filtration. Number 1, the first advantage is that it is fast, like filtration, it will be a fast filtration. The second thing, it will produce a dry solid or dry crystals, as it will remove the maximum amount. So it will be the first advantage, it will be a fast filtration. And the second advantage, it will produce a dry solid. Give two features of the results of a melting temperature determination, step 7, that would confirm that 2-ethonyl aminobenzoic acid was pure. So how we can identify whether a substance is pure or impure? So number one, it should have a sharp melting point and it will melt over like a range of 1 or 2 degrees, like narrow range will be there. And melting of the like the melting temperature should be consistent with the standard value, or like what standard value will have. So it will have a sharp or a sharp melting point or a small range. And the second thing is it should match with the standard value. Like every solid is having its own melting point at the standard conditions. It is having a fixed melting point. So it should have a, at a standard condition, like a fixed value should be there for this. Then part E, in the balance equation for this reaction, the mole ratio of 2-amino-benzoic acid to 2-ethyl 2-ethonyl aminobenzoic acid is 1:1. In an experiment, 3.7 grams reacted produced 2.42 grams. So this is the practical value of a product. Calculate the percentage yield. So percentage yield is a practical value divided by theoretical into 100. So if we use 3.7, we are getting 2.42. That's a practical value. But we have to find a theoretical value. So you have to take a ratio like C7, H7, NO2 and C9, H9, NO3. And the ratio is 1:1. So the mass ratio will be same. So first we'll take a ratio of the mass. You can work out in terms of moles or you can also work out in terms of mass. Like total mass of this one is 137 and total mass is 179. So if you have 3.7, so this will be X. Cross multiply using it. So it will be X is equals to 179 multiplied by 3.7 divided by 137. This will give us how much mass we should get. We should get about 4.83 grams. That is a practical value, but you need a percentage yield. So percentage yield is this is a theoretical value. Practical value was 2.42 divided by theoretical value 4.83 into 100. So it is about 50.1% yield. Like if we carry out this experiment, we'll get about 50.1% what we should get.